This is the example on slide 26 of our chapter 15 PowerPoint, and this question is asking us to identify the element that's oxidized and the element that is reduced in the equation written. So the easiest way to do this is by identifying oxidation numbers, which we just learned how to do, and basically figure out what changes are between the reactant oxidation numbers and the product oxidation numbers. So remember that when something is reduced, it's gaining electrons, it's gaining more negative charge. So therefore, when something is reduced from reactant to product, the oxidation number is going to become more negative. More negative is reduced. For oxidation, which is loss of electrons, our oxidation number from reactant to product is going to become more positive. Sorry, got a little tongue-tied there. So, have that written in the bottom for a guide. So the way we're going to start this problem is just by assigning every element in oxidation number either by itself or in a compound. So first we're going to look at CO2. Oxygen, whenever it's in a compound, always has an oxidation number of -2. And if I have two of them, they're contributing an overall -4 charge. Remember, we're trying to add up to 0. So that would make carbon +4. Now the oxidation number of the actual oxygen is just -2. But in order to add up to 0, remember we account for the fact that there's two oxygens. Hydrogen here, he's by itself in his natural elemental form, and if you recall, the rule for oxidation numbers is that this guy is going to be 0. Alright, moving on to carbon monoxide. Oxygen in a compound is always -2. And now, since we only have one of them, we have to add something to that to get our overall charge to 0. So carbon's going to be +2. And then in H2O, in water, oxygen's always -2, and in a compound, hydrogen is always +1. And we can check to make sure that both these numbers add up to 0. So if we have one oxygen that's contributing -2 and two hydrogens that are contributing +1, that gives us an overall net charge of 0. So that works out, that follows the oxidation rules. So now we're going to look and figure out what's being oxidized and what's being reduced. So here's where you look at the elements between sides and figure out if anything is changing oxidation numbers. So first thing I'm going to look at is carbon. On the reactant side, it's +4 oxidation state. On the product side, it's +2. So we're getting more negative here. We're gaining electrons. Therefore, carbon is undergoing a reduction. So, carbon is going from +4 to +2. It's gaining electrons in order to do that, so therefore it's reduced. Whenever we have a reduction, we have to have an oxidation. So now we can look at oxygen. Oxygen's -2 on the reactant sides, and it's also -2 on the product side. So that means oxygen's neither oxidized or reduced. So the only other element in our problem is hydrogen. And hydrogen, if we look, is going from 0 on the reactant side to +1 on the product side. So it's getting more positive. It's losing electrons. Therefore, hydrogen is undergoing oxidation. So to sum that up, carbon is reduced and hydrogen is oxidized. And there you have it. That's how to identify what's oxidized and what's reduced in a redox equation.